Hello, good day viewers. Remember, we have started treating limit of functions that do not exist. So in this tutorial, we have two other problems that we want to prove that their corresponding limits do not exist. Let me start with the first one. All right, here is the first one. We would like to evaluate the limit of the function, the absolute value of x divided by x, as x approaches 0. Because we have an absolute value right here, remember it is a piecewise function. If you have an absolute value of x, it could be positive if and only if x is greater or equal to 0, and it can be negative if x is less than 0. So now let us evaluate the left hand side and the right hand side limits, because for a limit to exist, both the left and the right hand side limits must be the same. So we have the limit as x approaches 0 from the left hand side of absolute value of x divided by x, and we also have the limit as x approaches 0 from the right hand side of absolute value of x divided by x. So now let us look at it on the number line. Suppose I have a number line here. We want to approach 0 from both directions. Let me start from the left hand side. If values of x approaches 0 from the left hand side, it implies that all these values are less than 0, right? So therefore x will be less than 0. So what condition is this? If x is less than 0, we are going to consider the absolute value of x as negative x. So this is equal to the limit as x approaches 0 from the left of negative x divided by x. And negative x divided by x is negative 1. And you should know that limit of a constant is still constant. So that will give us negative 1. So what about the other limit from the right hand side? If we approach 0 from the right hand side, all these values will be greater than 0. So x will be greater than 0. And if you have this condition, you have to consider the absolute value of x as positive. So this will be limit as x approaches 0 from the right of x divided by x. X divided by x is 1. Limit of constant, which is 1, is also constant. So this will give us 1. Can you see that left hand side limit is negative 1 and the right hand side limit is positive 1? Because they are entirely different, we say that the limit does not exist. Therefore, this limit does not exist. And you can look at it graphically. Let us move on to the second one. All right, we have the second problem here. We would like to evaluate the limit of the function e to the 1 over x as x approaches 0. So we have the limit as x approaches 0 from the left hand side of e to the 1 divided by x. And we want to also evaluate the limit as x approaches 0 from the positive direction, that is the right hand side, e to the 1 divided by x. Let me start with this one first. We'd like to evaluate the limit as x approaches 0 from the left hand side. Remember this function which we have treated earlier, which looks somehow like this. If you construct 1 divided by x, it is going to look like this, and like this. Remember, we have a vertical asymptote at x equal to 0 where the curve will never pass. So if you approach 0 from the left hand side, it is going to tend to approach negative infinity. And if you approach from the right hand side, it will approach positive infinity. So if you approach to the left hand side, this will become negative infinity. So this is equal to e to the negative infinity. And e to the negative infinity is the same thing as 1 divided by e to the positive infinity. E to the positive infinity is a very large number. Therefore, 1 divided by a very large number will approach what? 0. This will approach 0, right? So what about the other one? If you approach from the right hand side, the whole of this will approach positive infinity, which you can see here. So we have this to be equal to e to the positive infinity. And e to the positive infinity is also infinity. So you can see that to the right hand side, we are approaching positive infinity. To the left, we are approaching 0. Therefore, since the left-hand side and the right-hand side limits are entirely different, we say that the limit does not exist. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.